Hello everyone. As we have discussed about risk reliability and return period in our previous video, in this video we will be doing some numericals which have been asked in GATE on the topic risk reliability and return period. So the first question for you is a culvert is designed for a flood frequency of 100 years and a useful life for 20 years. What is the risk involved in the design of culvert? So basically, a culvert, which is a hydraulic structure, is designed for 20 years. That means 20 years is the life of this culvert. It is expected to serve its purpose for 20 years at least. So this 20 is the design life. I can say that design life, which I can denote with the symbol N, is equals to 20 years. Now for what flood it is designed? It is designed for a flood which has a frequency of 100 years. Now here 100 years is the return period. Frequency or return period, it's the same thing. The meaning is once in 100 years this flood magnitude is expected to occur. So 100 years is the return period. Now, if I say that 100 years is the return period, what is the probability of occurrence of that flood? I will say once in 100 years. So let me use the symbol P, which says the probability of occurrence, that is 1 by 100. Now, in order to find the risk involved with the design, what we have to do is risk is the probability of occurrence of this event, which is flood, at least once in 20 years. That means in the entire design life of 20 years, even if once this event occurs, the culvert will fail. Even if once the flood magnitude of such heavy magnitude that is not given in the question occurs, the culvert will fail. So that is the risk associated with the culvert. That is what the question is asking. So in order to find the probability of at least once, we can use the 1 minus probability of not occurring, because we know at least once means probability that it will occur once, twice, or thrice, or more. So by using the theorem of probability, summation is 1. So 1 minus probability of not occurring is equals to probability of at least once. So I can say what is the probability of not occurring by using the Bernoulli's, binomials probability. So here I can say that not occurring. So out of 20 years, no time this event should occur. So this small p is 0, and q is the probability of non-occurrence. That is 1 minus 1 by 100. I can say it is 99 by 100. This to the power 20. So if I solve it, I will get p to the power 0 is 1, 20c0 is also 1. So directly I can write it as 99 by 100 whole to the power 20. So when I solve it, the value that I get is 1 minus 0.8179, which I can further simplify and write it as 18.2 percentage. So basically you will get the answer in decimal. Later you multiply it with 100 to get it in percentage. So there is a risk of 18%, 18.2% with this culvert. Okay, so I hope you understood. See, this P and Q is probability of occurrence or non-occurrence on any given year. And what we are finding, probability that in the entire period of 20 years, this event is occurring at least once. Okay, it may occur on the first year, on the second year, or two times or three times, like that. So let's go to the next question. Okay, so our next question is, a temporary coffer dam is to be built to protect the 5-year construction activity for a major cross valley dam. If the coffer dam is designed to withstand the 20-year flood, what is the risk that the structure will be overtopped in the third year exactly? Now this is a different question. First of all, what is a coffer dam? Coffer dam is a temporary hydraulic structure that we build in order to start the construction. So when a dam is built across the river, so we have to vacate that space which is occupied by water. So a temporary coffer dam is constructed there to remove the water and to keep the land dry so that we can start our construction. So the design life of coffer dam is less, which is why it is given in the question. The design life is given as 5 years. Now what is given? This coffer dam is designed for a flood of 20 years. So here 20 years means once in 20 years this flood has the probability to occur. So I can say that probability of occurrence, which is denoted by small p, is 1 by 20, or I can say the return period t is equals to 20 years. Now, what is the probability that the flood event of such magnitude will not occur? So, probability of non-occurrence will be equals to 1 minus 1 by 20, which is 19 by 20. This is the probability of not occurring. Question is asking, what is the risk, what is the chance that the structure will be overtopped in exactly third year? That means for the first year the structure will be safe. So that means the probability of the occurrence of flood exactly in the third year, how are we going to calculate? It is equals to probability that first year it will not occur. So what is the probability? 19 by 20. Then second year, what do we want? It will not occur. And third year exactly this event should happen. What event? Flood. So probability of occurrence on any year, it is 1 by 20. So this is how we can find the probability of occurrence of the flood exactly in the third year. So we can write it as 361 divided by 1000, which is equals to, if you solve it, it will come out as 4.5%. So 4.5% chances are there, 4.5% risk is there that the structure will be overtopped exactly in the third year. Okay, if it is overtoppling in the third year, that is clearly saying that it will not overtopped in the first year and second year, right? So if it gets overtopped in the first year, then there is no point, the structure is gone. Okay, that is why the first 2 years it will be non-occurrence probability, and the third year we have to take the probability of occurrence. Okay, let's go to the next question. So in this question, probability that the annual maximum flood discharge will exceed this much magnitude at least once in next 5 years is given. 0.25, that means 25% chances are there that in the next 5 years such magnitude of discharge will occur at least once. So this is nothing but, we can say, let this flood event, let us say 25,000 meter cube per second, this event has a return period equals to t years. So if a flood event of this magnitude has a return period of t years, that means once in t years this event is occurring. So I can say that probability of occurrence is 1 by t, and this I am denoting with a letter small p. What will be the probability of non-occurrence, which I am denoting with the symbol q? Obviously it will be equals to 1 minus 1 by t. Now question is saying probability that this flood event occurs at least once in the next 5 years is given. So probability of occurrence of flood event having a return period t at least once in the next 5 years is equals to 0.25. Okay, so at least once means that probability, what are the chances that it will occur one time or two time or more than that in the next 5 years is this. So can I say that the probability of not occurring at all is equals to 0.75? Yes, 1 minus 0.25 basically. So what is the probability of not occurring in the next 5 years? Can I say 5C0, this P of 0, Q of 5. How can I say? Because Q is the probability of non-occurring and I want all the consecutive 5 years, not this event to occur. So I don't want this event to occur in the coming 5 years. So I am taking 0 time, like 0, P to the power 0 means no time it is occurring, and Q to the power 5 means all the 5 times means it is not occurring. So I can say that 5C0 is 1, P to the power is 1. So what I am left with, 1 minus 1 by T whole to the power 5 is equals to 0.75. So when I solve it, I will get the return period t equals to, so how will I solve it? I will take to the power 1 by 5 here and then I will take this 1 here. So while solving, I will get t, capital T, as 17.86 years. So return period of this flood event is 17.86 years. So I hope you understood this question. In this question, we have to find the return period corresponding to this flood event. Okay. And one thing to be noted, higher the return period, lesser is the probability of such event to occur. And higher the return period, higher will be the magnitude of the flood. So here we have seen this. Now moving on to the next question. Okay, so in this question, what is given? A flood of 4000 meter cube per second in a certain river has a return period of 40 years. That means this flood comes once in 40 years. There is a chance that this flood of magnitude 4000 meter cube per second can occur once in 40 years. Okay. Then what is the probability of accidents? What are the chances of this flood to occur? So definitely I can say the probability of accidents is 1 by 40. Yes or no? Because 40 years is the return period. That means once in 40 years it can occur. So that is the probability. Next part of the question says, what is the probability that this event of flood of more than or equal to 4000 meter cube per second may occur in the next 20 years? That means out of the next 20 years, maybe this event can occur one time, two time or three times. We don't know. What is the probability associated with that? We can definitely say that probability that the flood may occur is equals to definitely the probability that the flood does not occur at all in the next 20 years. This statement we are writing purely based on the theorem of probability, that probability of occurrence plus probability of non-occurrence is equals to 1. Either an event will happen or it will not happen. So how can I find probability that it is not at all occurring in the next 20 years? How can I find that? Using the binomial expression. So 1 minus 20 C0 p to the power 0 q to the power 20, where p, small p, is the probability of occurrence and small q is equals to 1 minus 1 by 40, non-occurrence. So here also I can write 1 minus 1 by t whole to the power 20 and t is 40. So I can write 1 minus 39 upon 40 whole to the power 20, which the value of this is approximately 39.73. This is how you can find that what is the probability that this event may occur in the next 20 years. Now next question of this is, find the probability of occurrence of this flood of magnitude less than 4000. So what we are finding is what is the probability that this flood does not occur. What was the probability of occurrence? 1 by 40. So what will be the probability of not occurrence? Very simple. They are asking what is the probability of non-occurrence of the flood. It is equals to 1 minus 1 by 40, which is 97.5%. So 2.5% chances are there that this event will occur. When will this event occur? If a discharge of 4000 meter cube per second or more than that passes through our hydraulic structure. And when will I say that it will not occur a flood of such heavy magnitude? Then I can say 1 minus of probability of occurrence. Yes, based on the return period, I can say this event will occur once in 40 years. Which event? 4000 meter cube per second discharge passing in a river. So, if I have to say what is the probability that a flood of less than that will pass, that means this event is not occurring. So, what is the probability of non-occurrence? 39 by 40. This is what it is. So, same thing I have, right? And later I have given all the answers in percentage. So these were the 4 important questions that I have selected to help you understand the topic risk and reliability associated with a hydraulic structure. It is to be noted that any hydraulic structure is designed for a flood magnitude of, let us say, some value of return period. The higher is the return period that you choose, lesser is the probability of occurrence of the flood and more is the reliability associated with that structure. Now, if you want to build dams and other major hydraulic structures, then definitely you will choose a value of high return period, because there will be less chance of such event of occurring. Usually a dam is of 50 years of design life. Okay, so we choose such a flood which has a return period of approximately 1000 years or maybe more than that. So it depends on what type of safety we are going to give to that structure. How much risk are we able to take for that structure? Okay, how much is the allowable risk? If you want to minimize the risk, definitely you have to go for the flood of high return period. And accordingly, when we design for such high flood value, our entire design process will be different. So in this two videos, I have tried to explain the use of risk and reliability and return period through the help of some examples. If you have any doubt with respect to the theory or in the numericals, you can feel free to put your doubt in the comment section. If you have liked the video, you must hit the like button and do not forget to share it with your friends. Thank you.